1, Lesson 7 on page 65. Today's topic is constant rate of change. Constant rate of change. It means the rate at which you're changing. Okay? We're still using ratios. We're still using simplest form. Those rules still apply. Okay, a computer programmer charges customers per line of code written. Fill in the blanks with the amount of change between consecutive numbers. Okay, so here's the lines of code. $50 lines of code, 1,000. 100 is 2,000. Okay, so I can see a pattern already, right? I mean, really, think about it. If you got rid of these zeros, it'd be 5 to 100, which, if we put in simplest form, is 1 over 20. Okay, so that's my guess. Let's see. Okay, well, here we're going up by 1,000 every time. 1,000 every time. Yeah, so it's constant. It's not going up by random amounts. The price is staying the same no matter what. No discounts. Okay? Then, here we're going up by 50 every time. 50, 50, 50. Label the diagram below with the terms change in lines, change in dollars, constant rate of change. Well, let me guess. This one's dollars, so let's guess this one's change in dollar. This one's probably change in lines. I mean, come on, it's written right there. And so that leaves this one being constant rate of change. Okay, $20. Let's see. Where did that 20 come from? Oh, remember? Our constant rate of change was, right? Costs, right? $20 per line of programming code, right? Same amount, right? They put 1,000 over 50, which was 20 over 1, which was what we got from doing simplest form. Okay? All right, you can use a table to find a constant rate of change. All right, well, let's take a look at this. The table shows the amount of money a booster club makes washing cars. Use the information to find the constant rate of change. Well, the first thing I immediately want to do is check simplest form, right? So 5 to 40, 5 divided by 5, divided by 5, 1/8. Okay, let's check a second one. 10 over 80, right? 10 over 80, divide by 5, divide by 5. Two and 16, divide by 2, divide by 2, be 1 over 8. Okay, so they have the same simplest form. So I bet this is a proportional relationship. Remember, it has to have simplest form. Okay, to be the same. Let me just adjust my camera. There we go. It's picking up too much of this other page. Okay, there we go. All right, let's see. So they say the first thing to do is find the unit rate. Okay, so that's what we've done here. $40 over 5 cars is $8 for one car. Okay, so then they said, so the number of dollars increased by $8 for every car washed. So that's us doing that. Basically, finding simplest form, finding the unit rate, that's basically the same as finding the constant rate of change. Just a different wording. Got it? So let's check. The table shows the number of miles a plane traveled. Use the information to find the approximate constant rate of change in miles per minute. So they've gone 30, 60, 90, 120. 290, 580. So at first I'm thinking, wait, 290, 580, this doesn't look proportional. But when I thought about it and I looked a little harder, I was like, okay, 30 to 290. Well, I know I can slash these zeros because that's like dividing by 10. So maybe 3 to 29 is that simplest form. And I thought, okay, well, what's 290? Well, this went up by times 2. So let's check it, 290 times 2. Oh, and sure enough, 580 is 580. So this one's going up by 290. This ones are going up by 30. So this says, find the approximate constant rate of change in miles per minute. So over here, you're going to have miles per some amount of minutes. Okay, so I would say 29 miles per 3 minutes. That's not quite taking it down to the unit rate, so we should probably do 29 divided by 3, right? Because this isn't quite right yet. Unit rate has to be for 1. So finish out the problem by doing 29 divided by 3. It's going to be a decimal, and get that decimal answer there. Okay? All right, the table shows the number of students that buses can transport. Use the table to find the constant rate of change. Well, again, we're starting at 2 instead of at 1, but 3, let's see if this is proportional. Well, what did this go up by? This went up by 1, 216 minus 144. Went up by 72. Interesting. Let's see. 216 plus 72. Okay, interesting. So I'm seeing a pattern. So I think that and this is going up by 1. So I'm guessing that the rate of change is 1 to 72. Another way you can check it is by taking this 2 over 144 and turning it to simplest form. We know this is 1. What is 144 divided by 2? Okay, so finish the problem here. Go ahead and finish it out for us. And constant rate of change in students. So you should have students. Okay, the number of students, whatever this answer is, per 1 school bus. Because remember, it has to be unit rate is for 1. Find the unit rate to determine constant rate of change. Okay, so let's look at this as far as a graphing goes. So remember, we talked about the test was it has to be a straight line and it has to pass through the origin to be proportional. Okay, so let's check. The graph represents the distance traveled while traveling on a highway. Find the constant rate of change. Okay, so we can do that by looking at the 1 to 60, right? And then this one's 2 to 120, yeah, which is double 60. So 60 miles for 1 hour. See how this is very proportional. Straight line going through the origin. Explain what the points 0, 0, and 160 represent. Well, 0, 0 represents traveling 0 miles in 0 hours, and 160 represents traveling 60 miles in 1 hour. So they ask you these same questions down here, so you can answer them in a similar way. It says use the graph to find the constant rate of change in miles per hour. So you want to look 1 hour and find out how many. Put that answer there. And then D, you explain it in the same way as they explained here, except they're asking about 0, 0, and 130. All right. The table and the graph below show the hourly charge to rent a bicycle at 2 different stores. Okay? And look down here. They asked a similar question, 2 different stores. Okay, so pay attention. So one they show a table, one they're showing a graph. This is pedals, this is supercycles. So which store charges more? Okay, well, let's see. This one's going up by 1, and this is going up by 12. So let me see. 2 to 24, these ones. Divide by 2, divide by 2. Yep, sure enough, 1 to 12. So this is 1 hour is $12. So pedals increases by $12 every hour. And let's look at supercycles. So 1 hour, so right here, they charge 8. Oh, and look at 2. Oh yeah, they charge 16. So supercycles charges $8 every hour. So it says which one charges more? Well, pedals charges more because they charge $12. Okay, so this one's more expensive. All right, let's look down here, building on essential questions. How can you find the unit rate on a graph that goes through the origin? Look at the value of 1 on the x-axis, or a whole number on the x-axis. Okay, you need to see where it hits a full dot, right? You don't want to use one that's only in between. You want to wait until it hits. Like, you don't want to use 0.5 or here when they're just sort of going through there. See, look, let's zoom in real close. See how these ones don't go all the way through it? You want to look and wait till you hit a corner, right? And then from there, you find the simplest form. Okay? All right, for our drawing today. Honestly, I forgot to look one up on the internet, but I was thinking how hungry I am. So, have you ever read that cute little book, The Hungry, Hungry Caterpillar? He just has all those cute little connected roly bits as he's eating, and he has these cute little feet going the whole way. All right. I hope you have time to get dinner or have already eaten, and I will see you in class.